The other kind of deformation is ductal deformation. And this kind of deformation is pretty much only found in areas that are experiencing compression. There's really not a lot of mechanisms where you can get folding during extension. So it's pretty much with compression. And the folds can be quite complex. So I'm going to turn off my face here so we can see that whole image. And the fold in front of these two geologists, we'll say they are, is if we trace it, so it goes up and down and back up and down and back up and down and then back up again. So a geologist is going to see this image and or go to this outcrop and make a sketch. And there's an unconformity across the top of the outcrop between the underlying, it looks like limestones and shales, and then quaternary alluvium at the top. The arches here that go up are called anticlines, and where the folds sink down, that's called a syncline. There could be more on here, but they've drawn in one axial surface through the middle of this anticline here on the right. So that's an anticline where the fold goes up, the syncline where the fold goes down, anticline again, and then back down. So these are made in areas where there's compression and the rocks just buckle under that pressure. A fold has parts to it. So here are the fold parts. The hinge is the line along the top of the fold. If you make a plane through all the hinges in the fold, the different layers, that would define the axial plane. The sides of the fold are the limbs. So limbs, axial plane, and the hinge right along the top. This one is the anticline. This is at an outcrop in Virginia. You can drive right down the highway and see this. An anticline, move my picture of me again. The anticline arches over like this. So in the image here, the cartoon, this is an anticline. The limbs, limb, are going to dip away from the hinge. The other kind of fold is a syncline. This is also in maybe Pennsylvania. So the syncline makes like a U shape in the fold, and the limbs are dipping down towards the hinge. So they dip down this way. So in the cartoon here, limb, hinge, it's making a sinking fold or a syncline. There are some folds that are kind of hidden. So in this case, this is, I've actually been to this spot several times in southern Utah, right on the banks of the San Juan River. And there's a blind fault underneath these rocks. So they make a kind of a half a fold, just one limb of a fold. Call that a monocline. Some folds plunge. So what we've seen just now are folds that just make arches with hinges that are parallel to the Earth's surface. If that hinge is not parallel and it dives down into the Earth, there we go, dives down into the Earth, then it can make really unique shapes on the Earth's surface. So here's a plunging fold. This is the Sheep Mountain, Wyoming fold. I've not been to this fold. I have been to the other one several times. And it makes this really unique landform. Part of that is due to the rocks, different sandstone layers having different erodibility. So like the sandstones didn't erode and the shales did. Folds start out as flat-lying beds. So here's the before picture. These are flat-lying beds. Compression has changed those units so that they fold up. I'm going to use old lab manual to show you what that looks like. So the flat lying, squeeze them together, and they fold. Whoop! There we go. Flat, fold. The axis here then is going to be at an angle. The fold hinge, we can trace it from this marker back away from us. Yeah. Horizontal compression causes rocks to buckle. Okay, so you squeeze it and they are going to buckle. That pressure then is coming in just directly at the bed. If you change that and it's more of a shear motion, then you're going to get kind of a zigzag or a Z fold, as in this image here at the bottom. Another ductile deformation is going to be tectonic foliation. So tectonic foliation is going to develop during shearing. Tectonic foliation is a little different than the metamorphic formation that we've talked about during our metamorphic rock lecture. In that metamorphic foliation, where you have directed pressure, the foliation lines up, right, as platy minerals perpendicular to the compression. When you have this tectonic foliation, you're shearing the rock, and the foliation is not going to be perpendicular to the compression. The shear motion just stretches out those minerals, and that defines the foliation.